So this is the first time I've ever used this stuff specifically, solder paste, and so I don't know how well it's going to work. Totally kind of an experiment. So we got to take this cap off, put the nozzle on, and then we're going to put the plunger on, and then I'm going to apply the paste, and then we're going to try putting on this board. So I have, this is the full board, but it's actually two boards in one. The top being a duplicate design of the bottom. And then so first thing I had to do is cut the board. Then when I was done cutting the board, I had to get the solder paste ready. And then the final thing, it doesn't look all that great. It looks kind of like it's not stirred up well. So like I said, I don't know how well it's going to work, but we're just going to give it a try to see what happens. So, all right. So we're going to put the paste on, and it comes out pretty fast, so I had to really shoot that. As you can see, as I'm putting it on, it just kind of goofed up there. And then we're going to try to put on those smaller leads of the same package. So that's a D-pack, and those are the leads on it right there. And it was coming out pretty fast. And so it created a problem for the smaller leaded parts like the IC, U3, and then some of the resistors. So it was difficult to use this paste, but I think if we'd shaken it up or stirred it up, it would have helped. So that there are some things you can do to make the paste work better, and a smaller nozzle would have been helpful too. So I'll put the IC on there, or this is like a regulator, and then we're going to put paste on U3. And when I put the paste on, it was hard to get it per each leg, so I couldn't just put a dab for each lead. So what I ended up doing is just putting paste all the way across, like you can see, and then the paste, when it heats up, it should separate itself, and you can see that later that it did, so it worked well. But yeah, I just put the paste all the way across. It's kind of a common method for leads that aren't too close together and too much paste. If there's too much paste, you'll have solder bridges, obviously. So it worked. Something to keep in mind, but it might not work for every IC. Like the IC above it may or may not work depending on how much paste you put on there. So I put the IC U3, and then I will put some solder paste on the resistors, and I'm actually putting caps on the resistor spots. Just as this is totally experimental. We don't know how well this is going to work yet. So I'm putting the caps on there. They're roughly the same, package size to fit on those pads. So I'm going to do that, and then we're going to put this whole board on a oven bread pan. One other thing I forgot to add was that you're going to want to have a decent tweezers. It doesn't have to be like a super expensive tweezers or anything, but you can add that to your expense list. But it's not like super crazy break the bank tweezer set, but just having some to place the parts. You could maybe place them by hand, but I with your fingers, but I definitely wouldn't do that. And I would also get a smaller nozzle for this kit, because the paste is not that thick, and like I said, so it comes out too fast. And there you can see I'm actually placing an actual resistor, and the other ones are all caps. And it's totally experimental at this point. This heater element is tied down with some wire. As you can see, you got some wire holding it down so it doesn't flop out on me. And I've got a bread pan, aluminum bread pan, that this board is going to sit in while we solder it. And this heater element, you could get any heater element from a crock pot, or maybe even from a coffee pot. Anything that's supposed for food preparation get hot. Okay, so now we're ready to start. We're gonna solder this now, and you can see that the solder paste is gonna slowly start getting sucked into the each spot where it's supposed to be, the joints, and the solder It's going to do that because it wants to bond to the hot metal. And it was kind of spread out there. And on the big pad, the top one that I'm pointing at with the pliers, that one takes a little longer because it's so much bigger of a part that it just takes longer for the heat to heat the pad up and heat all the solder paste up and get it melted so that it can, make a good joint. But otherwise, all in all, this is turning out pretty nice. It's looking, all the parts look pretty decent, and for no heat control, just plug it in and it goes 100% the whole time. I mean, it's the heater element is what you get, right? So there, you would worry a little bit about, components lasting if they get too hot too quickly or something. But one of the things I wanted to do is look under this microscope or magnification, and just see that, okay, like we didn't have any solder bridges between the leads. And this is the part that we added the solder all the way across, or the solder paste. And it did kind of gum up a little bit. The board must have gotten a little too hot, and so then like the solder mask kind of gets sticky. So you can kind of see that. But other than that, there's like not a ton of flux buildup that I can see. I guess the sticky stuff could be like flux residue. And then the big chip right there, the D-pack, it looks like it's soldered pretty well. It was a big part, so it took the longest, as you can see from the video. But yeah, the leads look great. I mean, maybe a little bit of a cold solder joint. I don't know like that. But yeah, you can see a little too much paste on that resistor, or a little too much solder. So we used too much paste there. But other than that, this is all done on a bread pan on a stove element.